So here we have the function secant of log of x raised to the power of n. So if we apply the property, the log of a raised to the power of b is equals to b log a. So this is equivalent to secant of n times log of x. Now we're going to apply the derivative. So we have the derivative of secant of n log of x. So here we're going to assume that n log of x is equivalent to x. Then all we have to do is find the derivative of secant of x, which is equals to secant of n log x times tangent of n log of x multiplied to the derivative of, I assumed function, which is n log of x. Now n being a constant, we can pull it out. So we have n times secant of n log of x multiplied to tangent of n log of x times derivative of log of x, which is going to be 1 over x. So finally we get n over x times secant of, so we can take the n back to the exponent of x. So we have log of x raised to the power of n times tangent of log of x raised to the power of n. So this is the required derivative. Let's move on to the next. So here we have the function given by square root of a squared minus x squared divided by a squared plus x squared. So let us rewrite this particular function by changing the square root to an exponent. So we have a squared minus x squared divided by a squared plus x squared whole raised to the power of 1 over 2. Now that means finding the derivative of the original function is equivalent to finding the derivative of the function written in the exponent form. Now we're going to assume that a squared minus x squared divided by a squared plus x squared, this is equivalent to x. Then we can apply the power rule, which is the derivative of x raised to the power of half. So this should give us half multiplied to x squared minus x squared divided by a squared plus x squared whole raised to the power half minus 1. So let's write it down. That is half minus 1 multiplied to the derivative of our assumption, which is a squared minus x squared divided by a squared plus x squared. So we have to find a derivative by using the quotient rule here. So that gives us half multiplied to a squared minus x squared divided by a squared plus x squared raised to the power of negative half. So now we apply the quotient rule. So we have a squared plus x squared whole squared. So in the numerator we have a squared plus x squared multiplied to the derivative of the numerator. So we have derivative of a squared minus the derivative of x squared multiplied to the numerator, which is a squared minus x squared multiplied to the derivative of the denominator. So we have derivative of a squared plus the derivative of x squared. So that gives us, so what we're going to do here, we're going to do a little bit of adjustment here. So we have half. So we have a squared minus x squared over a squared plus x squared raised to the power of negative half. So if we make the exponent to positive half, then what happens? The fraction flips. So that means the denominator, which is a squared plus x squared, will become the numerator, and the numerator, which is a squared minus x squared, will become the denominator. So then we find out a squared plus x squared multiplied to derivative of a squared, which is 0, minus the derivative of x squared, which is negative 2x, minus a squared minus x squared multiplied to derivative of a squared, which is 0, added to the derivative of x squared, which is simply 2x, whole divided by a squared plus x squared whole squared. So we have now half multiplied to a squared plus x squared divided by a squared minus x squared raised to the power of half times. So here we are going to take 2x as the common term. So let's take 2x as the common term. So we'll be left with negative a squared minus x squared minus, since we have taken 2x from the second term as well, so we'll have negative times a squared minus x squared, so we have a positive x squared here, whole divided by a squared plus x squared whole squared. Now the a squared, negative x squared and positive x squared will get cancelled, and the 2 and 2 will get cancelled, so that leaves us with x times negative 2a squared. So we have negative 2x a squared divided by a squared plus x squared whole squared multiplied to a squared plus x squared divided by a squared minus x squared raised to the power of half. So here we have a squared plus x squared, the term in both the numerator and the denominator. The numerator has the exponent of half and the denominator has an exponent of 2. So if we combine it, so we should get negative 2x a squared divided by a squared plus x squared raised to the power of 2 minus half multiplied to a squared minus x squared raised to the power of half. So that gives us negative 2a squared x whole divided by, so 2 minus half is going to be 3 over 2. So a squared plus x squared raised to the power of 3 over 2 multiplied to the square root of a squared minus x squared. So this is the derivative of the given function with respect to x. Let's move on to the next question. So this problem is quite similar to the previous one. So instead of a squared, we have 1 in both the numerator and the denominator. So we're going to solve it, but this time we're going to try a different strategy here. So let us begin by assuming that the given function is equals to y. Now what we're going to do here is we're going to square both the two sides. So we'll get y squared is equals to 1 minus x squared divided by 1 plus x squared. Now we're going to differentiate both sides with respect to x. So that means we'll find d over dx of y squared. And so also we're going to find d over dx of 1 minus x squared over 1 plus x squared. Now on the left hand side we have y instead of x. So we're going to assume that if y were equivalent to x, then we could have easily applied the power rule. So that means we have 2 times y raised to the power of 2 minus 1. But since this is not x, so we're going to multiply it to the derivative of y, which will be equals to, now we apply the quotient rule on the right hand side. So we have 1 plus x squared whole squared in the denominator. So we begin with the denominator, 1 plus x squared. Then we differentiate the numerator. So differentiating 1 is going to give us 0, minus differentiating x squared is going to give us 2x, minus the numerator, 1 minus x squared, which will be multiplied to the derivative of the denominator. So the denominator we have 1, so derivative of 1 is 0, plus derivative of x squared will be twice of x. So we have 2 times of y multiplied to dy over dx, which will be equals to negative 2x multiplied to 1 plus x squared minus 2 of x multiplied to 1 minus x squared whole divided by 1 plus x squared whole squared. Now solving the numerator, we have 2y dy over dx, so that will be equals to, so we're going to take negative 2x as the common term, so we'll be left with 1 plus x squared, since we have taken negative 2x, so we have plus 1 minus x squared in the numerator divided by 1 plus x squared whole squared. Now you can cancel out x squared, so we have positive x squared and negative x squared. So we have 2y times dy over dx, which will be equals to negative. So 1 plus 1 will be 2, so we'll be left with negative 4x in the numerator divided by 1 plus x squared whole squared. Now dividing both sides by 2y, so we have dy over dx, which will be equals to negative 4x divided by 2y times 1 plus x squared whole squared. So that will be equals to, so the 2 and 4, so leaves us with negative 2x over y multiplied to 1 plus x squared whole squared. Now we go to the beginning where we have assumed that the value of y is equals to square root of 1 minus x squared divided by 1 plus x squared. So let us substitute it back into our derivative. So we have derivative of square root of 1 minus x squared divided by 1 plus x squared. So that gives us negative 2x over 1 plus x squared whole squared. So we have 1 over y. So 1 over y will be simply the reciprocal of y, which is 1 plus x squared multiplied to 1 minus x squared. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function square root of 1 plus sine x divided by 1 minus sine of x. So here, before finding the derivative of this particular function, what we're going to do is we are going to simplify the given function. So we know that sine 2 of x is given by 2 times sine of x times cosine of x. Now if we apply the half angle formula, then sine of x will become equals to 2 times sine of x over 2 times cosine of x over 2. So let's plug in this value into a given function. So we have square root of 1 plus 2 times sine x over 2 times cosine of x over 2 divided by 1 minus 2 times sine x over 2 times cosine of x over 2. Now we know that sine squared theta, so I can say sine squared x plus cosine squared x is an identity which is always equals to 1. So similarly, we can also say that sine squared x over 2 plus cosine of squared x over 2 is equals to 1. So in place of 1, we are going to substitute with this particular value. So we'll have the numerator sine squared x over 2 plus cosine squared x over 2. So this has been written instead of 1 plus 2 times sine x over 2 multiplied to cosine of x over 2. So this is the numerator. Similarly, in the denominator, we'll have sine squared x over 2 plus cosine squared x over 2 minus 2 times sine x over 2 multiplied to cosine of x over 2. Now this was done so that now we have in the numerator the identity sine x over 2 plus cosine of x over 2 whole squared. Similarly, in the denominator, we have sine x over 2 minus cosine of x over 2. Well, what we can do is we can write the cosine function first. So let's do that. So we're going to write the cosine. That will become evident at the moment why I'm writing the cosine function first. So we have cosine of x over 2 plus sine x over 2 whole divided by cosine of x over 2 minus sine of x over 2 whole squared. So now we can get rid of the square root. So we have cosine of x over 2 plus sine of x over 2 divided by cosine of x over 2 minus sine of x over 2. Now we're going to divide both numerator and the denominator by and cosine of x over 2. So in the numerator, cosine of x over 2 divided by cosine of x over 2 is going to give us 1, plus sine x over 2 divided by cosine of x over 2 is tangent of x over 2. Whole divided by, similarly in the denominator, we are dividing by cosine of x over 2. So the first term in the denominator will be 1, and the second term will be tangent of x over 2. So now what we can do is we can replace 1 with tangent of pi over 4, because we know that tangent of pi over 4 is equals to 1. So we have tangent of pi over 4 plus tangent of x over 2 divided by 1 minus. So here we can say that 1 is multiplied to tangent of x over 2, such that we can replace that 1 by 10 pi over 4 multiplied to tangent of x over 2. Now this has been done because this is the expansion of tangent of pi over 4 plus x over 2. So here we are using the expansion of tangent of a plus b, which is given by tangent of a plus tangent of b all divided by 1 minus tangent of a times tangent of b. So our entire function has now simplified. So square root of 1 plus sine x over square root 1 minus sine x. So let's write it down. Square root of 1 plus sine of x divided by 1 minus sine of x is actually equivalent to tangent of pi over 4 plus x over 2. So let's find the derivative. So we apply the derivative on both sides. So derivative of the tangent function is going to give us secant squared, assuming that this entire pi over 4 plus x over 2 is x. So we have pi over 4 plus x over 2 multiplied to the derivative of pi over 4 plus x over 2. Now derivative of pi over 4, meaning the constant, will be 0, and derivative of x over 2 is simply going to be half. So our final value will be equals to half secant squared pi over 4 plus x over 2. So let's move on to the next question.